Hello, I am Signar Baez, Principal Architect for MongoDB, and I would like to walk you through our operationalized data warehouse solution that is based on Google BigQuery, AutoML, and MongoDB Atlas running on Google Cloud. Our customers want to provide their end customers with the best systems of experience, gaming, commerce, collaboration, and so on, while relying on a cloud architecture that can serve and enrich data continuously and seamlessly. In this video, I will show you how MongoDB Atlas and Google BigQuery are complementary technologies. Atlas can handle the real-time operational load, serving hundreds of thousands of concurrent sessions with sub-millisecond query response time. And from Atlas, we can then take curated subsets of data and publish to BigQuery for aggregation, complex analytics, and machine learning. Together, they enrich the operational data and can elevate the customer experience. For this demo, we're going to focus first on the sync architecture concern and demonstrate how data can travel both ways in near real time. And then combine datasets from both Atlas and BigQuery to train machine learning models that can be used to predict and enrich the user experience. So let's imagine we are tasked with building a film producer advisor app. The beta launch of the app will help the film producers make decisions about their movie by predicting audience ratings. The app will be used when scouting locations in the beautiful city of San Francisco while considering different directors and cast. Let's start with the initial load. As you can see, the code is quite simple. We simply connect to the Atlas cluster, define a table that we will write our data from Atlas into BigQuery, read from Atlas using Google Cloud Dataflow, and transform the JSON document into a table row, and eventually write into BigQuery, again using Google Cloud Dataflow. Here is our Atlas cluster named ODS, running on GCP and the Oregon or US West 1 region. And what's great about this demo is that all the data that is needed in Atlas is already available using the sample datasets. These have already been preloaded, and here's an example of what the movies collection in a JSON document for a movie actually looks like. Awesome. Here is BigQuery. I've created a dataset called mflix, and notice there are no tables. That's because the table we will use to move data from Atlas to BigQuery will be created on the fly by Dataflow. And here are my Dataflow jobs. Notice there are no movies load jobs running. And now using a Google Cloud VM, let's fire off our Dataflow job. And once it is fired off, we should see the job appear in the Dataflow control panel. And once it's available, we should be able to inspect the different steps and transformations that are occurring to move data over. And there it is. Let's click on it, and well, it might be too early as it's still running, but there it is. Awesome. Notice how Apache Beam, which is actually Dataflow, is firing off for MongoDB I/O reads as well as for BigQuery I/O writes, and we can even expand, the steps inside each of the Dataflow or Apache Beam jobs. Great. So now let's just let this complete. And it is complete. Awesome. And now back to BigQuery, we see our movies table with all the data that we moved over from Atlas. And there you go. Outstanding. We all know change is the only constant. New movies get released, data for existing movies gets modified, and so on. To keep data in sync in real time, we're going to use MongoDB's change streams. Change streams are a key component of our Kafka connector, but for the purpose of this demo, we are going to use Cloud PubSub and Cloud Dataflow. This Java class is acting as a CDC source connector. In MongoDB, to respond to changes in real time, programmatically, all we need to do is call the watch method on a collection. In this case, I'm going to watch all movies. That sounds funny. And for each movie, I am simply going to call this code block and publish a message to PubSub. It's that simple. And now we need a CDC sync connector. This Java class is going to consume or read topics from PubSub. And that topic obviously includes the message and the data. And use, again, Dataflow and Apache Beam to send the data over into BigQuery. Simple. Let's use a fictional movie called Real-Time Rules and ensure it does not exist in BigQuery. And there we go. Now, both the sync and source connector have already are running and on standby. And to fire off an event, we are simply going to insert a new movie by cloning an existing movie and just changing the title. Let's go ahead and do this. And let's erase the ID and change the title to Real Time Rules with one. Let's make sure I don't max out. So now the moment I press insert, we will see the source actually connector process that document. Ready? 1, 2, and 3. There it is. Super fast, incredibly fast. And now if I go into BigQuery and fire off the previous query, we should see that record. And done. Simple. And now let's obtain insight by analyzing both sets of data in BigQuery. For the purpose of this demo, we are going to use the San Francisco film locations available in BigQuery sample datasets and cross-analyze that against our movies dataset. This query analyzes both sets of data and obtains the number of locations in the city of San Francisco that have been used for each particular film. And we place that in a column called numlock. Let's place the insight gathered in another temporary table. Let's call it movie insights. We can then use this table to enrich the ODS via Dataflow and PubSub. Here are the source and sync connectors from BigQuery into Atlas. As you may have guessed, they follow the same approach. Use PubSub and Dataflow to decouple and move data between two systems. But where it gets really interesting is at the point of enriching the ODS, in this case Atlas. MongoDB's dynamic schema, which is battle tested for many years, lets you change the shape of a single JSON document or a set of documents with new fields at any time without requiring schema changes to the database. This is incredibly useful for data science teams, as over time they can evolve and use other data sources or algorithms to produce new insights that can drive better user experience, advice, and innovation of their products and services. Going back into Atlas, let's ensure that there are no movies that have the numlock field, number of locations. And correct, there are 0 movies. Here are both connectors running. On the top is the sync connector that's awaiting for insights that are being published to the topic of PubSub. And on the bottom is the source connector that is about to iterate through the insights. And there it is. Now, all that insight is being written into Atlas. Now, let's go and find movies that were enriched. So, there you go. Let's see, The Jazz Singer, 2 locations in San Francisco. San Francisco, the movie, 4 locations only, and many more. Excellent. How about movies that were not enriched? How about when the field does not exist? And likewise, we do have movies that were not enriched. Why? Because they did not have matching data in BigQuery sample dataset. Perfect. Let's add machine learning to our solution. First, we need to train a machine learning model, and to train my model, I need more data. So I've imported the full sample movie set from Atlas, which includes my director, cast, and IMDb rating, along many other fields. I can then use this full dataset to be joined against BigQuery's sample datasets that includes the movie locations, and now obtain the location of the movies. This view can then be used to train a machine learning model. I have done that up front, and I'm going to try and predict the IMDb rating, that is my target column, by using the cast, director, and location. You can actually train multiple models from the same dataset. In this case, I have two. One that uses every single field, basically the full dataset, and one that only uses the fields that I'm interested in. I'm going to use this one. Via the Google Console UI, you can test out the prediction in the API. Let's try out Keanu Reeves in cast, Lena Wachowski as the director, and the financial district as the location. Can anybody guess which movie this is? This is The Matrix. And yes, 8.681 actually can go as high as a 9, and that is actually the score of The Matrix. Perfect. Now, we all know that we are going to have to call this programmatically, not through a UI. So let me show you that as well. Okay, let's invoke the same values, but now via the API, so that we know it still works. And there it is, Keanu Reeves, Lena Wachowski, Financial District, and the same prediction. Awesome. Now, let's try another set of values, and this time I'm going to invoke the API twice for the same movie, but with a different actor and actress. Let's see if you can guess this movie. Sally Field, directed by Chris Columbus, and filmed, or at least one of the locations was 100 Embarcadero Street, and also Robin Williams for the same. I'm sure you guys by now, this is Mrs. Doubtfire, one of the favorite movies of my daughter. With this demo, we were able to demonstrate that it is now even easier to provide a differentiated and intelligent experience for your customers by using Google Cloud's machine learning capabilities and a modern and flexible general-purpose data store like MongoDB Atlas. Thank you so much.